Hey all, welcome to homeschool. This is your class 11 mathematics. We are in our first chapter sets and today we are going to start exercise 1.4. Before starting this exercise, we are going to have a tiny introduction about Venn diagrams and operations on sets. What are Venn diagrams? Most of the relationships in sets can be represented by using diagrams. Those diagrams are called as Venn diagrams. Venn diagrams. Universal set. It contains all the subsets, right? Universal set is represented by a rectangle. Okay? And universal set is denoted by U. Universal set is denoted by capital U and right inside the rectangle. And other subsets are represented by using circles. Okay, suppose let me take one subset. Let me take one circle and let me mark on top of it capital A. A set I am representing here, and let me write the elements inside. If you want, you can put a dot and you can represent, or normal number you can write off 1, 2, 3, 4, 5, 6. See here, try to understand the Venn diagram carefully. In universal set, what are all the elements present in universal set? All the elements you say here, 1, 2, 3, 4, 5, 6. Right? All the elements inside the rectangle. All the elements in this rectangle belongs to universal set. Now, if I consider a subset A, what are all the elements of A means? We are going to say only the elements inside the circle. That is 1, 2, 3. 4, 5, 6 does not belongs to A set. Yes? Now, this is a subset of the universal set. All the subsets can be represented by using circles. Now let me take one more Venn diagram. This is a rectangle. Universal set. U is represented here. And take a circle A and one more circle inside this. Mark this as a B. Right? And write the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. See here, A and B are the two subsets of universal set. Now identify the elements in universal set. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? All the elements are scattered inside the rectangle. Next, identify the elements of A. A circle. What are all you can see here? 4, 5, 6, 8, 9. 4, 5, 6, 8, 9. B, don't write B. B is another set. Right? B is a set, not an element here. Now, what are all the elements in B set? Only 8, 9. See here, when you have two circles like this, I can say that B set is a subset of A set. B set is a subset of A set. How it is possible? Look here, B set 8, 9. 8, 9, these two elements are also present in A set. So, B is a subset of A set. Directly by saying here, you can say B is a subset of A. B is a subset of A. Okay, like this, how many sets you are going to take? You can represent with different circles. Right? Next concept, operations on sets. Operations, what do we know till now? Addition, multiplication, subtraction, division, right? But in sets, the operations are different. What are those? Union of sets, intersection of sets, difference of sets, and complement of sets. So now we are going to discuss union, intersection, and difference, and then continue the exercise. Operations on sets. First one, union of sets. In operations on sets, first one, union of sets. Union of sets, before knowing this, I am going to explain this by using a tiny example first. Suppose if I take sets, more than one set. So I am going to take here two sets. A is equal to 1, 2, 3. And B set 3, 4, 5. A is equal to 1, 2, 3. B is equal to 3, 4, 5. Union of these two sets. Union is usually denoted by the symbol U. Okay? And A union B. And this is usually read as A union B. Okay. Before writing the answer, easy to understand union. Union, you remember a word, combine. Union means combine. A set and B set combinedly write the elements in A union B. All the elements of A set and all the elements of B set and the common elements are written one time. 1, 2, 3, 3, 4, 5 there, right? Which number is repeating here? See, observe, 3 is repeating in both the sets. 3 is there in A set and 3 is also there in B set. So what is a union definition? All the elements of A and all the elements of B, repeated elements taken one time. Okay? Semi combinedly 1, 2, 3 is repeated. So write only one time, comma 4, 5. That's it. A union B is equal to 1, 2, 3, 4, 5. Finished. So how do you write this symbolically? A union B is equal to set of all x such that x belongs to A or x belongs to B. When we are talking about union, you should remember or. Now let's see the definition of union of sets. The union of set A and set B is a set C in which all the elements which are present either in A or B set, and including the elements which are common in both the sets. Now we are going to draw the Venn diagram for A union B. Venn diagram, draw a rectangle. Always draw a rectangle. This is universal set, right? A and B, two sets, right? Two circles. Do you have any common elements? Yes. You have common elements, right? Here you have 3 is common. Common number where you are going to write? I am going to write common number here in middle of this. See here, this part what you can see, this is common for both the subsets A and B. A and B. Now other than common elements, what are all the elements there in A? 1, 2, 3. 3 already I have written. So write here 1, 2. Anyway, you can write in the circle. Next B. Other than 3, 4, 5. Now we are going to learn shading. What shading? A union B shading. A union B shading means, see here. shade complete two circles. This shading represents A union B. See here, in a separate box you can indicate. See where I have shaded, this indicates A union B. Or on top of box also you can write A union B. Right? Without elements also you can show the shading. How can you show? A and this is B. Like this you can show the shading of two sets without any elements. A union B means complete A circle and B circle. Okay, this represents A union B Venn diagram. Okay, always universal set is compulsory. And if you want, you can check your answer. What is the answer of A union B? 1, 2, 3, 4, 5. See the shading? 1, 2, 3, 4, 5. All the elements, these places are all shaded. Right? You can compare your answer with the shading also. This Venn diagram is only for this example. And this is a common Venn diagram for A union B without any elements. Okay, next comes to intersection of sets. Intersection of sets. Intersection of sets is represented by the symbol inverted U. Inverted U is a symbol to represent intersection. How do we read this? A intersection B is equal to set of all x such that x belongs to A. Here what we have taken or. In intersection we are using and x belongs to B set. What is the definition of intersection of sets? Intersection of two sets A and B is a set consists of common elements present in both the sets. Okay, let us take the same example. Let us take same example. A is equal to 1, 2, 3 and B is equal to 3, 4, 5. Intersection of sets A intersection B is equal to. What is A intersection B? X belongs to A and X belongs to B. The elements which are common in set A and set B. What are the common elements? You can see 3 is common in both the sets. So write only that element. This is A intersection B. And how we are going to represent this in Venn diagram? Draw a rectangle first. Universal set represented by capital U. And then two sets A, B. Right? Shade only this part and say this is what? A intersection B. Okay, with the small tiny box also you can say, see what I have done in this Venn diagram, this shading represents A intersection B. Like this also you can say. Okay, intersection, common in both the sets. Common in both the sets A and B. If you want to write elements, you can write there. See here 1, 2, 3, here 4, 5. All the elements you need to write and shade only the part where you have 3. Okay, is this clear? This is about union and intersection. Easy to remember: union, combination. Intersection, common. Combination, if in both sets if you have same element, write one time. And write all the remaining elements. Combinedly you write in union. Intersection, write only common element. This is about union and intersection. Union we use with or, intersection we use with and. So A union B is equal to set of all x such that x belongs to A or x belongs to B. A intersection B is equal to set of all x such that x belongs to A and x belongs to B. Next, let us see the properties of union of sets and intersection of sets. First, under union, let me write the first law. A union B is equal to B union A. What is this? Do you remember? Yes, it is commutative law. What it is? Commutative law. Same manner, we can write commutative law for intersection. What is that? Instead of union, write intersection. A intersection B is equal to B intersection A. Same you can write commutative law. Next property. A union B union C is equal to A union of B union C. So what is this? It is associative law. Associative law. Similarly, say for intersection, A intersection B of intersection C is equal to A intersection of B intersection C. Same law you can write, associative law. Next, A union phi. A union phi is what? Okay, let me take an example here. A is equal to 1, 2, 3. Phi means it is null set, right? Empty set. There are no elements present in it. Either this or this, both are same. There are no elements in this. A union of phi. A union phi means union if you do, there is nothing, no element in this. So union of these two is again 1, 2, 3. I can say 1, 2, 3 is nothing but A. This is called as the law of identity element. Law of identity element. A union phi is equal to A. Law of identity element. Similarly, if I take an intersection, A intersection phi is equal to A intersection in A set and phi. What are all the common elements? Means there is no common elements. I can say it as phi. A intersection phi is equal to phi. A union A. A union A is equal to. Suppose if you take the same set again and do union. Union means what? Combinedly write the two sets. 1, 2, 3, 1, 2, 3. Same elements are repeated in both the sets. So write one time. That 1, 2, 3 is nothing but again A set. A union A is equal to A. This is called as idempotent law. Okay? And the same manner, A intersection A. A intersection A. Suppose if I take same sets, what are the common elements in both the sets means? You will write A only. Yes or no? In both sets, same elements are present. So A intersection A is also A and A union A is also A. Same idempotent law you can say. Next one. Universal set union A. Universal set union A means, observe here, universal set contains all the subsets. A is one of the subset. Right? When you do union for these two sets, your result will be universal set. In universal set, A is also a subset. Right? This is called as the law of universal set. So, intersection. See there? A or U intersection A you can say, or A intersection U you can write. A intersection universal set. A intersection U or U intersection A also you can write. So, understand here, A is one of the subset. One subset intersection of universal set means you are going to get the same subset. In universal set, along with the A set, other subsets are also present in universal set. When we are talking about intersection, only common we should say. So, A and U, what is common? A is common. So, this is also comes under law of universal set U. So, next we are going to write one more law, that is distributive law. A intersection B union C is equal to A intersection B union A intersection C. Intersection is distributive over union of sets. So what you can say? Distributive law. Distributive law, you can say this as intersection is distributive over union of sets. How can you write the statement? Intersection is distributive over union of sets. So come again, once again, these properties of union and intersection. A union B is equal to B union A intersection B is equal to B intersection A. This is commutative law. A union B of union C is equal to A union of B union C. A intersection B of intersection C is equal to A intersection of B intersection C. So this comes under associative law. Then law of identity element, A union phi is equal to A and A intersection phi is equal to phi. A union A is equal to, if both the sets are same, then its union will be the same set. Idempotent law. And A intersection A is also A. Universal set union with any subset, it will be universal set. Universal set intersection with any subset, that subset is your result. Okay, this is called as law of universal set. And another law, what we have seen now, distributive law. A intersection of B union C is equal to A intersection B union A intersection C. Intersection is distributive over union of sets. All these properties are important. So try to remember these all properties. Let us draw Venn diagrams, small Venn diagrams for all this. Look here carefully. A union B, you know already. B union A also, you know how. A circle and B circle will be shaded. Then coming to A intersection B, the intersecting part of two circles will be shaded. Same manner B intersection A. Now coming to A union B union C, Venn diagram we are going to see now. A union B union C. Look here carefully, a rectangle, universal set. Here three sets I am talking. So take three circles A, B, C. A, B, C. A union B, that means A and B circle. Union C means all the three circles you need to share. Yes. Next, RHS side, what you have? A union of B union C. That means first you shade B and C. A union means all the three circles again you shade. So same Venn diagram you can say for A union B union C also. Okay, coming to A intersection B intersection C. Look the Venn diagram here. Rectangle, universal set. Do three circles. A, B, C. Okay. A intersection B of intersection C. First always see the bracket one. A intersection B means see this part. Right? Intersection C. C circle, look here. This region, okay, roughly I am shading here. See this shading, where it intersects the C circle, only this part. That means you need to shade only this part. See, observe carefully. A intersection B means from here to here you need to shade. But you have one more intersection with C. So this region, Where it intersect with C circle means only this part. So only this part you need to share. That represents A intersection B of intersection C. RHS you see here, B intersection C. B intersection C means this part, right? A intersection, A circle, what is a common place to shade this part and this circle? Same children, only this part shows the Venn diagram for either this or this. Okay, next let me see for this A intersection B union C. Okay, let me draw one more rectangle and A intersection of B union C. How many sets are there? 3 sets, right? So draw 3 circles A, B, C. When you are doing 3 circles like this, you try to draw children A, B, C and this is universal set. First go for brackets B union C. Okay, first think but don't try to shade first. B union C means what? B and C circle. A intersection. See, observe here, B and C circle. What is the intersecting part for A circle? See here, I think this is a part, right? See, only this part we need to share. This indicates A intersection of B union C. Once again, what you have in brackets? B union C. So complete B and C. Keep in mind but don't shade first. Still you have here A intersection A circle and B union C. What is the common part? See this part. This is the region where you need to share. Okay. So same manner, let's see that one. A intersection B. A intersection B means this part. A intersection C means this part. So these two union, this part and this part union is this one. So let's try another Venn diagram. Okay, let me go with A union B intersection C. Rectangle A, B, C. A, B, C. Universal set. A union B means these two. Right? These two circles. Intersection C means, see, only this part we need to share. Okay, is this clear? Try to understand Venn diagrams. They are very simple. Now let's move to the third operation, that is difference of sets. Let's see the next one, difference of sets. The difference of two sets A and B in the same order. A and B I am saying. Suppose let me take A is equal to 1, 2, 3 and B is equal to, same example, 3, 4, 5. Okay, if the two sets A and B in the same order, the elements belongs to A and the elements does not belongs to B. That means difference of these two sets can be represented as A minus B is equal to set of X such that X belongs to A set. But X does not belongs to B set, right? And you can write here and X does not belongs to B set. So what is the final answer? Difference of these two sets. Difference of both the sets, I can say here A minus B. Just you remember. A minus B, how can I find? Shortcut to remember. In A, remove B set. In A set, remove B set means in B set, what are all the elements you can see? 3, 4, 5. In A set, do you have any element belongs to? Yes. See here, 3. Other than 3, you write the set. Other than the B set element, what are common you see? First, 3 is common in both the sets. Other than 3, write the answer. 1, 2 is your answer. In A set, remove B set. In A set, remove B set elements. Other than 3, you write and say that is your answer. A minus B is equal to x such that x belongs to A but x does not belongs to B. So let's draw the Venn diagram for this. A minus B. Rectangle, universal set, A set, B set, A, B. First, when you are doing Venn diagram, common elements right here. Common elements means 3 here. Other than 3, what do you have in A? 1 and 2. And B set, other than 3, what do you have? 4 and 5 here. Okay. A minus B. In A circle, remove B circle. And shade remaining part. This is only A minus B Venn diagram. Other than B circle, shade the remaining part in A circle. Okay. Now, let us find B minus A. We have seen A minus B. Now, B minus A. Have to remember this. First circle in B. In B, remove A circle elements. In B, remove A circle element means 3. Remove 3 in B and write 4, 5. That is only your answer. Okay. B minus A. How we are going to show the Venn diagram? Rectangle, universal set, A, and this is B. B minus A. In B circle, remove A circle. This is the region where you need to shade. Okay, if you want, write the elements also like this. We are going to write and shade only where you have 4, 5. There only you need to shade. This is nothing but the difference of sets. And how do you write symbolically B minus A? B minus A is equal to x such that x belongs to B, but x does not belongs to A, right? So, and x does not belongs to A, right? Is this clear? Now, we are going to see, suppose if you get A minus B answer as pi and B minus A as pi, or A intersection B as pi. See here the conditions when A intersection B is phi and A minus B is phi and B minus A is phi, then we call them as disjoint sets. How will be the Venn diagram? Look here. A, no common elements. A intersection B is equal to pi means what is the meaning? There is no common elements. No elements. Pi means no elements, right? A intersection B is empty set. You can write A circle separate and B circle separate. And this is A intersection B. You can say these type of sets as disjoint sets. There is no joint in between the two circles. There is no common. So if common there, we can do the intersection part. But there are no common elements means we can write the circle separate. Okay. See here A minus B is equal to pi. A minus B pi means in A if you remove B there is no element. In A if you remove B there is no element in A. That means also you can write A set separate and B set separate. If you get the answer pi, then you can do the Venn diagram in this manner. And these sets we call them as a disjoint sets. Let's start the exercise 1.4. Find the union of given each pair of sets. In this first problem, x is equal to 1, 3, 5, y is equal to 1, 2, 3. Find the union. So what do you remember here? X union y. Set of all x such that x belongs to capital X or x belongs to y. Right? So directly you can write off answer or you can use this one. X union Y is equal to. Now observe the two sets. Do you have any common elements? 1, 3, 5. 1, 2, 3. Yes, 1 and 3 are repeated in two sets. So what you are going to do? Repeated elements, write one time and write all the elements. That is 1. After 1, you have 2 in this set. 1, 2, 3, 5. Don't write again 1, 3. Repeated elements, write one time. Okay, that's all. That is your answer. 1, 2, 3, 5 is the answer. Next one. A is equal to A, E, I, O, U. See a square bracket this side you can see in your textbook. Don't worry, A is included. And here B is equal to A, B, C. Observe the two sets carefully. Do you have any same elements? A is repeated in both the sets. B, C not there. Right? Only A element is repeated. So how we are going to write? A union B is equal to set of all X such that X belongs to A or X belongs to B. That is A union B is equal to. Now write all the elements here. A after B, C here, there. So in an order we need to write. A after you have E, don't go on writing E. Just check after A what will be there? B. B is there in another set, you can continue writing there. A, B, C. Again come back. E, I, O, U. This is your answer. It's very simple. Right? See the third one. A is equal to set of all X such that X is a natural number and multiple of 3. X such that X is a natural number and it is a multiple of 3. Multiple of 3, what do you remember? Okay, let me write this. Let us write this in roster form first. X is a natural number and multiple of 3 said. So let me write the multiples of 3, 3, 6, 9, so on. Where it ends, I don't know. Multiples of 3 said. Where it ends, they did not say. Right? Next, coming to B. Set of all X such that X is a natural number less than 6. It is very simple. Natural numbers less than 6 means 1, 2, 3, 4, 5. 6 won't be there. Now, observe these two. 1, 2, 3, 4, 5, 3, 6, 9, so on. How can I write this union? See here, A union B is equal to X such that X is equal to. I will write 1, 2, 4, 5. 1, 2, 4, 5. I did not use 3 because 3 is there in this. Or a multiple of 3. Observe here. Or a multiple of 3 I have written. So this completes your answer. So what is your answer? A union B is equal to set of all X such that X is equal to 1, 2, 4, 5. Because in that statement multiple of 3, here 3 there and in this set also 3 there. So I did not use 3 here. 1, 2, 4, 5 or multiple of 3. Where it ends we don't know. So all the multiples of 3 according to the given question I have written the answer. Okay, is this clear? So if you have any doubt of rule method, convert into roster method, understand and again rewrite your answer in rule method. Okay, let's move to the next problem. A is equal to set of all X such that X is a natural number. X is what? Natural number. And X is greater than 1 and less than or equal to 6. Okay, write it in roster form. X greater than 1. Greater than means 1 is included or excluded? Greater than 1 won't be there. 1 is excluded. So write the next natural number 2, 3, 4, 5 less than or equal to symbol there. Means 6 is included. Next B. B is set of all x such that x is a natural number and x is greater than 6, less than 10. Greater than 6. 7. All natural numbers I am talking here. 7, 8, 9. Less than 10. So 10 not be there. So how will you find A union B here? Observe the numbers carefully. 2, 3, 4, 5, 6, 7, 8, 9. Greater than 1 you have, less than 10 you have all the natural numbers. So while you are writing in answer, A union B is equal to, if you want you can write first in this way, A union B, 2, 3, 4, 5, 6, 7, 8, 9. But your question is asked in rule method. Okay, set builder, so accordingly we need to write the answer. Set of all x such that x is greater than 1 and less than 10 for all x belongs to natural numbers. By using comma you can write all natural numbers. What are all the natural numbers? The numbers which are greater than 1 and less than 10. Okay, in this way you need to write the answer. See the last one in this main. A is equal to 1, 2, 3. B is equal to null set. Null set, empty set or pi you can say. So what is A union B? A union B, empty set and A set union, what you are going to get? You are going to get just 1, 2, 3. That is nothing but A union B is equal to A set. Okay, is this clear? Second one, let A is equal to AB, B is equal to ABC, E is A subset of B. What is A union B? First question in this, is A subset of B? Look here, in A what do you have the elements AB? In B do you have these elements? Yes, A set is a subset of B set. AB elements of A are there in B set. So therefore A is a subset of B. What you are going to write here? Yes, A is subset of B. What is A union B? A union B. X such that X belongs to A or X belongs to B, you write. And directly I am saying the answer here. A union B. In A and B, observe first which are the common elements. A, B, B. AB is repeated in 2 sets. So repeated elements what we need to do? Write one time. A, comma, B, comma, still extra what do you have? C. That's it. This is only A union B. Third one, if A and B are 2 sets. If A and B are 2 sets such that A is subset of B. What is A union B? Suppose A is subset of B. Let me take this example only. Right? A is equal to AB and B is equal to ABC. Okay, A is subset of B. Then what is A union B? We got A union B answer also above. What is A union B? A, comma, B, comma, C. What is A union B? They did not ask you ABC as an answer. This ABC set, the elements ABC contain set. That is nothing but B set. So therefore what I can write? A union B is equal to B. That's it. Right? What is A union B? A union B is equal to B. Fourth problem. If A is equal to set of 1, 2, 3, 4, B is equal to 3, 4, 5, 6, C is equal to 5, 6, 7, 8 and D is equal to 7, 8, 9, 10. You have 4 sets given here. Find A union B. What is A union B? You know that? Set of all x such that x belongs to A, or union means you should remember or x belongs to B. A union B is equal to. Now see A set and B set. Observe what are all the common elements first. 3 is repeated here, 4 is repeated, 3 and 4 are repeated. Repeated elements, write one time and write the remaining elements. Start. 1, 2, 3, 4. In this set, already 3, 4. There it is repeated. I have written already one time. No need of writing again. Other than 3, 4, what do you have? 5, 6. That's it. See the second one. A union C. A union C is equal to set of all x such that x belongs to A or x belongs to C. A and C, right? X belongs to A or x belongs to C. That is A union C is equal to. Observe A set and C set. 1, 2, 3, 4, 5, 6, 7, 8. Is there any common element? There is no common element. So continuously write the elements in A and C. 1, 2, 3, 4, 5, 6, 7, 8. That's it. Okay. So let's move to the third problem. B union C. B union C is equal to set of all x such that x belongs to B or x belongs to C. B and C set, right? So B union C is equal to. Observe B set 3, 4, 5, 6 and C set 5, 6, 7, 8. So in these two sets, 5 and 6 are common in both the sets. So 5, 6 write only one time and write all the remaining elements. So right now 3, 4, 5, 6, 7, 8 is your answer. What is B union C? 3, 4, 5, 6, 7, 8. So next one, fourth one, B union D. B union D can be written as set of all x such that x belongs to B or x belongs to D set. All the elements of B or all the elements of D. Repeated elements, write one time. B union D is equal to B set and D set. Observe 3, 4, 5, 6, 7, 8, 9, 10. Is there any common elements? No common elements. So write continuously. 3, 4, 5, 6, 7, 8, 9, 10. That's it. Okay. See the next problem, fifth one. A union B union C. How can I write this one? A union B union C is equal to set of all x such that x belongs to A or x belongs to B or x belongs to C. In a single line you need to end this. Now A union B union C. Observe 3 sets. Is there anything common? Here in these two sets 3, 4 is common. And in these two sets 5, 6 is common. So 3, 4 and 5, 6 write one time. And write all the remaining elements. So start writing from A. 1, 2, 3, 4. 3, 4 is repeated in this set. Other than these two, you say remaining 5, 6. See 5, 6 already repeated and I have written in this set. So skip these two and write remaining 7, 8. So therefore, what is your answer for A union B union C? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So let's move to the sixth one. A union B union D. A union B union D can be written as set of all x such that union, or you should write, okay, x belongs to A, or what is another letter? B. X belongs to B, or x belongs to D. That means A union B union D is equal to, observe, A, B, D. In A and B, 3, 4 is common. B and D, nothing is common. First, write the elements of A and B. 1, 2, 3, 4, 5, 6. Next, D. 7, 8, 9, 10. That's it. This is your answer. Coming to last one. B union C union D. B union C union D is equal to x such that, set of all x such that x belongs to B, or x belongs to C, or x belongs to D. Now write the elements. Now write the elements in the answer. B union C union D. B, C, D. B and C, 5, 6 is common. Write one time. C and D, 7, 8 is common. Write one time. So start from B. 3, 4, 5, 6. C set, already 5, 6 written C. Next element 7, 8. And here already 7, 8 written. Remaining elements are 9, 10. Therefore, B union C union D is equal to 3, 4, 5, 6, 7, 8, 9, 10. Union. Combinedly write the elements. Repeated elements write one time. Fifth main, find the intersection of all the problems what you have done in first main. So, I have written all the questions from first main. See the first problem, x is equal to 1, 3, 5, y is equal to 1, 2, 3. Intersection. What is the symbol? Inverted U. X intersection y is equal to set of all x such that x belongs to capital X, and while you are writing intersection, you need to write and. X belongs to y. X intersection y is equal to, intersection, write only common elements from both the sets. 1, 3, 5, 1, 2, 3. Which is common element here? 3 is common in both the sets. So your answer is 3. Second one in it, A is equal to A, E, I, O, U. B is equal to A, B, C. A intersection B is equal to set of all x such that x belongs to A and x belongs to B. Okay. Now observe both the sets. Is there any common elements? A is common in both the sets. Do you have B here? No, only A. Therefore, your answer is only A. See the third one. Third one in your textbook you have set builder form. But I have written in roster form. Right? Now find A intersection B. A intersection B is equal to set of all x such that x belongs to A and x belongs to B. Okay? A intersection B is equal to, observe the two sets, 3, 6, 9, so on. Where it ends we don't know. It is an infinite set. And here you have a finite set. 1, 2, 3, 4, 5. Among these, do you have any common element? Yes, 3 is common in both the sets. Therefore, your answer is 3. A intersection B is equal to 3. So, next one. A is equal to 2, 3, 4, 5, 6. B is equal to 7, 8, 9. Find the intersection. A intersection B is equal to set of all x such that x belongs to A and x belongs to B. A intersection B is equal to the set of common elements in both the sets. What are the common elements? Here you have 2, 3, 4, 5, 6 and here you have 7, 8, 9. Do you have any common element? No. You can just go with null set. Therefore, your answer A intersection B is equal to null set. Coming to fifth one, A is equal to 1, 2, 3, B is equal to null set. A intersection B is equal to X such that X belongs to A and X belongs to B. A intersection B. Observe A set 1, 2, 3, B is empty set or a null set. So do you have any common elements in both the sets? Yes. What is that common element? Null set. Null set is common in both the sets. Okay. With this we are going to complete our fifth main. Sixth main. If A is equal to 3, 5, 7, 9, 11, B is equal to 7, 9, 11, 13, C is equal to 11, 13, 15, D is equal to 15, 17. These are all the elements in the given 4 sets. Find, there are many questions, so directly we can answer all this. Observe carefully. First one, A intersection B is equal to A set, B set. What is the symbol you have here? Intersection. Intersection means only common elements. Observe 3, 5, 7, 9, 11. 7, 9, 11. See here, these three are common in both the sets. So only write common elements 7, 9, 11. That's it. Right? See the next one. B intersection C. B set and C set. In these two sets, what are the common elements? 7, 9, 11, 13, 11, 13, 15. See here, 11, 13 is there in this set and 11, 13 is also there in C set. So what are the common elements? 11, 13. Okay. See the third one, A intersection C intersection D. Oh, 3 sets common elements you need to write. What are the 3 sets? A, C, D. A and C, do you have any common elements? No common elements. And D and C, you have 15. But all these 3 sets, do you have any common elements? Okay, suppose if you have a doubt, you can write here. A set, what do you have? 3, 5, 7, 9, 11. And C set, 11, 13, 15. D set, 15, 17. Do you have any common same elements in 3 sets? There is no common element. See here, for these two, 15 is common. For these two, 11 is common. Right? But comparing to 3 sets, intersection of 3 sets means the same element should be present in all the 3 sets. Do you have any such element? No such element. So no means what is your answer? Null set. Okay. See the fourth one, A intersection C. A 3, 5, 7, 9, 11. C 11, 13, 15. So what is a common element in this set and this set? 11 is common. Okay. Are you able to understand? Listen carefully. It is very easy. Next one, B intersection D. B set 7, 9, 11, 13. D 15, 17. Do you have any common element? No. No means null set. Sixth one, A intersection B union C. See here children carefully. If you have these type of problems, have to proceed. First do B union C. Okay, first let me find B union C answer. B union C. Union means combination. Repeated elements write one time and write all the remaining elements. B union C. 7, 9, 11, 13, C set 11, 13 already I have written. So extra what do you have? 15. Okay. Now this set intersection with A set. So if you want, you can write A set here. 3, 5, 7, 9, 11. Now write your final answer. A intersection of B union C is equal to. Do you have any common elements? Observe here. 7, 9, 11. 7, 9, 11 you have. So what is your answer? 7, 9, 11. Intersection. See, B union C, B and C set, union you have done. So what the result you get? That set intersection with A. Then when you are doing intersection, you can see 3 common elements. That is only your answer. See the 7th one, A intersection D. A 3, 5, 7, 9, 11. D 15, 17. Do you have any common elements? No common elements. So it is null set. 8th one, A intersection B union D. Same pattern, do slowly. What you have in brackets, you do that one. That is B union D. B union D. 7, 9, 11, 13, 15, 17. There is no common element. So write all the elements which are there in B and D. 7, 9, 11, 13, 15, 17. Now A intersection B union D. See there, A what you have? 3, 5, 7, 9, 11. See 3, 5, 7, 9, 11. Oh, these 3 are common. So when I say A intersection B union D, there are 3 elements which are common in both the sets. They are 7, 9, 11. 9th one, A intersection B of intersection of B union C. So how to do this type of problems? First do the brackets separately. A intersection B is equal to and B union C is equal to, separately you find out. Later you do the intersection of both the answers. A intersection B already you have done. What is the answer? 7, 9, 11. Have you done B union C? Yes. Here you have 7, 9, 11, 13, 15. 7, 9, 11, 13, 15. Now, intersection of these two sets. A intersection B, A intersection B, intersection B union C. Observe intersection there. Intersection means common elements. Same elements what you have here and here. 7, 9, 11 is common. So write the answer as 7, 9, 11. Okay. So the last problem. A union D intersection B union C. First find out A union D. What is A union D answer? 3, 5, 7, 9, 11, 15, 17. 3, 5, 7, 9, 11, 15, 17. And B union C. What is B union C? 7, 9, 11, 13, 15. A union D intersection B union C is equal to. So intersection of these two sets, observe carefully what are the common elements. 7 there, 9, 11 and 15. So your answer is 7, 9, 11, 15. Right? Therefore, with this, we are going to complete our 6th main. With this, I am going to end my session. In our next session, we are going to continue with the next problems. Until then, keep watching. Thank you all.